How does one pellet produce immense nuclear energy? Have you ever wondered how a tiny pellet can generate such vast amounts of energy? It's fascinating how something so small can have such a big impact. Let's break it down. A nuclear fuel pellet is a small, dense ceramic piece made mainly of uranium dioxide. These pellets are about the size of a fingertip but contain a massive number of uranium atoms packed tightly together. The magic happens when we talk about nuclear fission. Inside the pellet, there are uranium-35 atoms. When a neutron collides with a uranium-35 nucleus, it causes the nucleus to split into smaller parts. This splitting releases a tremendous amount of heat energy and additional neutrons. Those new neutrons can then strike other uranium atoms, creating a chain reaction. Now, why does this process produce so much energy? The energy released from each fission event is millions of times greater than what you would get from burning coal or gas. This is because nuclear fission converts a small amount of the atom's mass directly into energy. Following Albert Einstein's famous equation, energy equals mass times the speed of light squared. So, how does this tiny pellet turn into electricity? Hundreds of these pellets are stacked into metal tubes known as fuel rods. Many fuel rods come together to form a fuel assembly, and multiple assemblies make up the reactor core. In the reactor, the heat generated from fission heats water, turning it into steam. This steam then spins turbines, which generate electricity. The principles of thermodynamics are at play here. The heat from fission is transferred through the reactor's cooling system to water, converting it into steam. The steam's energy is then transformed into mechanical energy by turbines, and finally into electrical energy by generators. Even though one pellet is small, the energy it produces is immense. For instance, one pellet can generate as much energy as an entire ton of coal. This high energy density means that nuclear fuel is very efficient, producing a large amount of electricity from a small volume of material. In essence, one uranium fuel pellet produces immense nuclear energy because the nuclear fission process releases a vast amount of heat from splitting atomic nuclei. This heat is harnessed through thermodynamic processes to generate electricity efficiently.